that better? Okay, sorry about that. So I was working in China with a company in China who does all the credit card processing for China, and they run their business and the credit card authorization on DB2. And we were talking about Expo in Shanghai. And the Expo in Shanghai was going to be completely cashless. So all the tickets you purchased, all the food you purchased, everything that was going to be purchased in the Shanghai Expo event was going to be done through credit card source. So you're going to have this authorization go through the database of it. And he was terrified of the workload that was going to hit the system. He was terrified of what would happen if he took an outage during this event. And unfortunately, none of those things happened. But we've taken a lot of those experiences on how to build out systems of these incredible levels of transaction throughput and availability to put into the systems. When we talk about building out on the experience we've gained over the years with customers, with POCs, with benchmarks, and building that into the system. The next concept is integration by design, and it really then means actually designing this into the system in a much more detailed fashion, so that the capabilities are there for you and they're there for all your workloads. And as I go through the presentation, I'm going to talk about more of the details of what we've actually done, how we've actually optimized the performance. And finally, the simplified experience. And the simplified experience, I just can't understate how important this is. When people talk about cloud environments, a lot of the concepts in clouds are really, again, getting associated with this DevOps model. And this DevOps model is moving to a paradigm where your developers, your end users, are deploying the systems. The end users and developers are the ones that are administering and managing the systems. So the complete operational model is changing. And they don't have nearly the sophistication that you would normally see in an IT shop. So you have to, again, build in the simplification. So if you look at the Pure Data Transaction System, it's a system that arrives ready for you. It's a combination, and it's a design that takes your compute resources, it takes your networking layer, it takes your high-speed interconnect, it takes your storage technology. It's built that into the system. It's taken the actual clustering capabilities of DB2, the DB2 Pure Scale technology you heard discussed earlier, mapping that onto the architecture, making sure that we optimize for the memory, optimize for the SSD that's in the system, and optimize for the hard disk drives, and deliver that capability very quickly. So the system arrives at your site. It's completely factory integrated. It arrives at your site. You put it on the floor. You plug in 4 power cables. You plug in 4 network cables, and you're ready to go. You're ready to actually load data, start deploying systems. We've also built in patterns. And you've heard the concept of patterns as part of your application system. And in the database world, this is a slightly different system than the application system, where the application system is allowing you to actually build out applications and deploy applications on the system. And in this system, you're actually just running the database software. So the database patterns are allowing you to actually deploy cluster topology. So you're actually dynamically deploying clusters and actually deploying then the database into that cluster with self-provisioning paragraph. So you've got these models for patterns. And as I've discussed, we've got intelligent solid-state disk and memory. I'm going to go through the details of how we use that and the benefits as I go through. And a tightly integrated management and monitoring infrastructure. And again, I'm going to give some more details on this. So let's talk about the simplified experience. There was a recent report by Forrester that looked at IT projects in general, and they found about 34% of IT projects actually deploy late. And as they dug into this more, and they looked at the cost, 45% of the cost actually was associated with just defining the hardware topology, getting the hardware installed, configuring it, integrating it, managing the firmware updates. So a large percentage of the overall cost was just associated with these aspects. Another 35% of the cost was associated with doing the same thing to the software. So installing the software, configuring it, tuning it, reconfiguring it, testing it, patching it. So what I'm going to do is now I'm going to walk through an example of what it would take to define a database cluster. And when I talk about a database cluster, what I'm talking about is a shared disk architecture. And this shared disk architecture, for those of you who've been around, is modeled after the DB2Z. I'm Canadian, so the Z2 is my American friend. Sys-Flex architecture. So the first thing you would have to do is you have to define the hardware you want to use, what servers you're going to use. You're going to have to configure your servers. You're going to have to define what kind of networking you want to use, what kind of interconnect, how do you configure the interconnect, what the storage layer is, what levels of redundancy you want in your storage controllers and your switches. So you have to go through those operations. You then have to take a look at the software layer. You have to install the software on the system. You have to configure it. You have to configure the operating system. You have to configure your database layer. You have to configure your network systems. So there's a lot of effort to configure that. When you get into the storage subsystem, you have to decide what kind of RAID array are you using. Are you going to use RAID 5 or are you going to use RAID 6, RAID 10? What kind of actual topology are you going to use in your storage layer? How are you going to define your storage pools to the database? You have to install the database. If you have a complex system like this, you need a management infrastructure. You need a management infrastructure that's going to monitor the system, make sure you understand how well the system's performing, and if it doesn't perform well, what's going wrong, how do you do diagnostics. That management infrastructure needs to have high availability, so how do you set that up? You've got to have your database members configured, you need to have a backup strategy, a recovery strategy, you need to have capability of testing and tuning all that. So there's a lot of effort that goes into defining these clusters. And what we've done is we've taken, again, all our experience and we've configured the system in such a way that you're going to have a self-provisioning mechanism which will automatically create and deploy database cluster topologies on the system. So this is a very simple process. We basically will specify the name of the cluster, the size of the cluster, the version of the software you want to run. We actually support different versions and different fixed packs on the system, so you have flexibility from that perspective. And it deploys the system in a matter of a couple of minutes. So we've talked about the topology patterns. I'm just going to dig into them a bit more. So if you look at, again, a topology, it's going to be a cluster. So let's take a cluster with 6 servers. You're going to have 6 servers. You're going to have an interconnect. It's an RDMA-enabled interconnect. You're going to have fiber channel connectivity to your storage devices and full redundancy at that layer. The storage is shared across your cluster. So now you've got a cluster of systems. You need to be able to spread that workload across the cluster. And this is where the DB2 Purescale capability comes into play. So it allows you to actually deploy the cluster and then you spread workload in. So when you actually connect into this cluster, the client layer automatically deploys data across that cluster in a uniform way. So we're balancing the workload across the cluster to ensure that we're using all members in the cluster efficiently. What we do is we return information back from the individual nodes to the client, giving weights of the CPU utilization, memory utilization, I/O levels. And we use that information to determine what's the least busy member in the cluster. And we then route that transactions to that least busy member. So we have a lot of intelligence that allows you to manage and make sure you're getting efficient utilization on the cluster. If you have a failure in the cluster, so if one of those 6 servers crashes, that's automatically detected by the system. We will reroute client requests to the other nodes. We have a very fast fencing of the I/O mechanism, and we use a SCSI 3PR algorithm to do a fencing of the I/O to make sure you don't have split brain mechanisms. We recover whatever data is in flight in the transaction log, and then we'll, if possible, bring that member back into that server back into the cluster, reintegrate. All of this is again fully automated. So when we talk about these cluster topologies, all those cyber capabilities are built into it. Now the next panel is actually deploying databases. So you have your cluster, and now you want to deploy databases. And there's 2 ways you can actually deploy a database into a cluster. You can have a one-to-one mapping. So if you have the most mission-critical application, so let's say you have an online banking application, credit card authorization system, an online commerce system, you can actually put that in its own cluster so you have complete isolation of the workload. So you completely isolate out the workload. And the other capability you have is to actually allow multiple databases to be defined into one cluster topology. Now this is a multi-tenant type